This video will contain lessons about expected value. So we're looking at the first problem. The first problem that we're looking at is this: suppose a certain game is fair. That's a key word, and we'll come back to that. And it costs $3 if you lose and has a net payoff of 9 if you win. The only possible outcomes of the game are winning and losing. That's it. You either win or you lose. So what's the probability of winning? Well, the probability of winning we will make as X. So that means that the probability of losing, a loss, would be 1 minus X, seeing as 1 is 100% certainty, right? So I told you about suppose a certain game is fair. I said that's a key thing, right? The expected value of a game that is fair is equal to 0. So let's think about this. We've got this right here would be for the loss, right? Negative $3, if cost should be negative $3 times the probability, right? Plus $9 if you win times the probability of winning, right? You set it equal to 0, distribute, you get negative 3 plus 3x plus 9x, and then you're solving that little equation. You get x equals to 1/4. Now, so the probability of a win is equal to x, so x is equal to 1/4 or 0.25, or you could say you win 25% of the time, theoretically, right? Okay, now, questions off of number 1's problem. Any questions? Yeah. Don't. It's a video. You can come back and write down things later. Well, we don't know what the probability of a win is, so we're setting it equal to x. X is an unknown, right? But if you tell me you know what the probability of a win is, then I could tell you what the probability of a loss is, because it'd be 1 minus that. Because 1 is 100%, right? 1 is a decimal of 100%, right? 100% is equal to 1 as a decimal. How about that? Okay? So you either have a percentage of winning, probability of winning, or probability of losing. But the highest you can get is 100%, right? You can't get any higher than 100% of winning, which would be 1. So if we know that the probability of winning is 0.25, that's what we solve for, right? Well, the probability that you would lose would be 0.75. That would mean you would be losing 75% of the time. Fair enough? It only asked for what was winning. So it's a multiple event, right? Winning or losing, okay? All right, any other questions on this one? Okay. All right. The table. The table is to me the easiest. And I'm going to put expected value as EV. Expected value is EV, right? It's basically probability times the score, plus the probability times that score, plus probability times that score, plus probability times that score, plus probability times that score. If you think about it, if you look right here, we've done the probability. Here's 1 minus x, and here's x. Those are probabilities times a value, right? -3 or +9. Well, they just gave you all the values in a table, right? Which is pretty cool. So all you have to do is 0.15 times 3 plus 0.2 times 4, 0.2 times 10, right? Plus 0.15 times 11. Got 11 of those, right? Or the probability of getting 11 is 0.15, right? and the probability of getting a 12 is 0.3. And if you would add all these up, they should equal 1. So what the expected value of a random variable, meaning a random score, the probability of it or expected value would be 8.5. That would be what your expected value would be based off of the probabilities and the scores provided in the table. So this one is really a chug and plug. Fair enough? Now, any questions on that? No? Y'all are all still there? Like everybody's still there? We're like, yeah. Okay. Okay. All right. Let me go back to my stuff then. All right. Here's the third one. A company estimates that 0.3%, that's 0.3%, right, of their products will fail after the original warranty period. Okay. So if they say a warranty period's a year, right? You go to Best Buy, they will warranty it for a year, right? Anything after a year, you got to go to the manufacturer. That's why they sell extended warranties, right? But within 2 years of the purchase, wait. A company estimates 0.3% of their products will fail after the original warranty period, but within 2 years of the purchase with a replacement cost of $200, right? So 0.3% of the products that they sell will fail within 2 years. And their replacement cost is $200, right? Now, if they offer a 2-year extended warranty, right, for $15, what's the company's expected value of each warranty sold? Okay. So here, the P means probability, right? The probability that you're going to have to replace it is 0.3%, which is 0.003. Okay. The probability of not replacing it, well, if it's 0.3% to replace it, the probability of not replacement would be 1 minus that, right? Same thing as we had back on the first problem, 1 minus it. That's how we got the 99.7, right? It'd be 1 minus 0.3, right? Which gives you that. Now I changed it into a decimal. Now the cost of the replacement is $15 minus 200, right? See, it's going to $200, but you're going to pay $15. So it's really only going to cost the company $185 if you buy that, right? Now, the revenue from the non-replacement, that means, hey, if we don't have to replace them, we just made $15, right? So either we're going to lose 185, or I say lose, it's going to cost us $185, or we're going to gain 15, right, for the revenue. Now the expected value would be this. This right here would be is if we had to replace, right? Negative 185 times the 0.003 plus if we don't non-replace, that'd be the $15 times the 0.997. Well, if you multiply those and add them together, your expected value, the company would still be able to have an expected value of $14.40 for every warranty that they sell. Their expected gain would be that much. So does it benefit a company to sell a warranty? Yeah. I mean, $14.40 every time they do that. Now, is it going to cost him some? Yeah, but it's 0.3% of their products fail within the first 2 years. So it's a very low probability, right? So for me to offer a warranty as a company, dude, I'm making money. Because if I'm building good product, that will last more than 2 years, and my probability is 0.3% that the products will fail within the 2 years of purchase, I'm making bank, right? I mean, I'm selling a extended warranty for $15, but in the outcome, the expected value, even with the 0.3% of things failing, I'm still making $14.40. So really, I'm only losing 60 cents, right? I'm only 60 cents out of that $15 is the only thing I'm losing, right? So that's a pretty good percent of return, right? So, but anyway, that's the three that I've got right now. I'll have more. Okay.